Hack Night. NeurotechX is an international community that facilitates the advancement of neurotechnology. Our pillars are community, education, and innovation. We have chapters worldwide, over 5,000 members on Slack, and check your local area for your own chapter. If you don't have one, please get in touch. We can help you set one up. Same goes for student clubs. You can check your college or university, and if not, get in touch. We can talk to you about what's involved. If you're not already on Slack, check the meetup agenda for a quick bit.ly link. And if you're looking for some information, you can always try the online educational platform at neurotechxedu.com. We've also got newsletter and job board. And good. So welcome. Another week. And yeah, lots been happening this week, and really excited for the presentation today. I haven't actually. So Ian Mcintyre is going to be coming at 7. But this week, I don't know if anybody caught. We weren't really the time zones that were targeted, but did anybody catch some of the Oxford's Autumn School Neuroscience? It was, really great speakers, but just, yeah, I'm gonna catch them offline. And the Bernstein conference as well has been going on, which had so many fascinating breakout sessions, which I did catch a little bit of, but anybody signed up for that? John, was that kind of up your, I mean, there was going to be some simulations.
Yeah, but I'm taking a break from conferences.
Oh, okay. Good.
That's what's going on at the moment.
Sure.
I mean, it was a very conferencey summer.
Yeah, well, and
so there's lots of good stuff for sure, but
next week
it's too much.
Yeah, next week is just crazy. It's I don't know if you, I mean, in the meetup, it's Mcintyre, SPR. What else have we got here? Well, as well as it's GTC West. So if you're, there's going to be a lot of good GPU deep learning stuff that's happening. BCI Samara. So.
Wait, sorry, I didn't hear that last one. BCI Samara.
Yeah. So if did you check the meetup information?
I have not seen the meetup information. Well,
gotcha.
for this one, but I haven't seen the meetup information for that one.
If you scroll down on the kind of like agenda, I have links to all the kind of conferences and workshops that are going on next week.
Oh,
hey Morgan, can I ask you a question about the agenda?
Yeah.
Is that ROS Neuro as in robot operating system?
It is.
Oh, sweet. I went to ROSCon in South Korea a few years ago.
Nice. Okay.
Yeah.
So
that'll be awesome to hear about.
So, yeah. So it's got my learning ROS with Python.
Yeah.
And but it's really cool. I mean, the ROS Neuro, sorry to jump ahead, but the ROS Neuro is really interesting in the sense that it's super like LSL. Or
cool.
ROS itself is already LSL-ish in that it's publish and subscribe, right? And so yeah. Anyway, I'm interested for people to have a look at this because it's the most, well, I mean, it's BMI for ROS, right? Like that's what they've tried to add.
Yeah, I might want to use that for a project that I'm working on with the robotics lab. So I'm really excited to hear about that.
Yeah. Yeah, what's the status of that? Isn't it a challenge you guys are working on?
Yeah, so we're really going to start hitting the ground running with it over the next few weeks. I think the semifinals are in January, so we're really, going to start working on a lot now. And now that I have the Notion, I think that's probably the device that we're going to try to integrate into using in Unity right now. But that part of it uses a virtual reality system to control, so we can use Unity for that. But then we also want to look into just EEG and EMG based control without VR, and they're already using ROS, so that integrates perfectly.
Yeah. I mean that's something that they talk a lot about in their paper, is that like too many projects keep these separate, and it doesn't make sense. And what I'm super interested in is, of course, like ROS is great, and you don't need hardware.
Yeah.
Like you can just do it all simulation. That's kind of the whole point. And yet be absolutely ready to embody that because you've got so many devices that are ROS compatible.
Cool.
And anyway, so
can you expand on that a bit? I mean, what is ROS exactly?
So ROS is the robot operating system, and this has kind of become the. I don't want to say that because I'm not really in robotics. Maybe Jaden would agree. Like it's the middleware that everybody uses now.
Yeah, virtually every robotics lab that I can think of uses ROS in some capacity. And so if you buy a robot from some company, there's a 90% chance they'll have a ROS package available for it, and that's probably what you'll use to communicate with it. And so that has it's like publisher and subscriber messages for things like, joint orientation stuff, just so you don't have to deal with all of the back-end SDK stuff of that robot.
Yeah. And so since it has a nice name that works well with NeurotechX, I like to check RobotX. So there are also some really great challenges that are going on. Maybe Jaden can drop a link in the. You've dropped a link before, I think, right?
Yeah, I'll drop a link to the challenge and then also to our team page.
But DARPA has Sub T was the DARPA challenge that happened recently, and again, the cool thing being that they were also rolling out all these cool cloud-based simulation tools that you could play with first. And even if you didn't have hardware, you could essentially play with somebody's real hardware system, or at least it would behave like that. And what you could focus on is, of course, what's the control system that you're going to have for it, right? Yeah. And some of these robotic simulations are crazy realistic. And so why I like this particular one, this RobotX one, is that at ROSCON, they had an international team worked on making the water work. Because it's like if you're essentially building a robot ship, right? You need not only to have realistic conditions for people to deal with, but you also needed the ship to behave as much as a real ship would, because if your simulation isn't realistic for that, so it's the same thing in the sense that the people doing the coolest simulations are generally, are the people whose tools that we ride on for doing the coolest EM simulations are the people who are doing kind of turbulence simulations and that kind of computational fluid dynamics and so the what's the group in Norway? It's they make Phoenix, spelled Fenics. It's sim. I'm gonna look them up, but their whole institute is we model turbulence because you mathematically can't really define what it is.
Yeah, turbulence, and like I know I got a few packages when I tried designing a wind turbine, and then I just kept crashing my computer every time I tried to run a simulation because it fluid dynamics or robotics, or like if you're trying to combine both, is so, at least 10 years ago it was incredibly hard. But Ross and all of these packages are now starting to be easy to integrate. Like I have a couple friends who are working on getting Ross into Unity because
So I'd love to hear about that.
yeah, it's useful for autonomous robots. I mean, my friend actually built a simulation of the real world for a self-driving car company to test their lidars virtually. Their lidar system
Gotcha.
in virtual reality.
Sure.
So, like Unity is great because so many things can be put into it, and like I'd love to use a EG headset to try to control a robotic arm in Unity and then pass it once that works well. See if I can just hand it off via ROS to an actual robot arm. Like use Unity as the intermediary step for testing and simulation.
So
And model building, some kind of GANs or something on millions of instances within a simulation.
They've definitely got a well-developed, machine learning, reinforcement learning, agent add-on or package, or and that's coming directly from the Unity group.
Yep.
And so why I of course thought about Unity, or like I was wondering what kind of connections there might be. Because somebody was talking about recently, like how much Unity is used outside of game development.
Oh yeah, yeah. I mean, I've been trying to look at some stuff. Yesterday, I did a binge looking at their new HDRP workload, which is their high definition, high realism pipeline where all the objects can have ray tracing, path tracing. The object material designs, everything's designed to be more realistic, and they actually allow ray tracing in VR. With it barely runs on even a stupidly high-end computer, but it's the closest we can get to insane high fidelity testing environments for simulations. Because one of the cool things about Unity's camera is that camera component can simulate any sensor. You can literally program in the camera that is viewing that world to be its own sensor from any number of camera companies. It could be an infrared sensor, laser sensor. You can change focal length, every aspect of the camera, and create simulated cameras to look through or at objects, which is pretty nice for ROS systems. And I think it could be, there's a lot of cool things. Later on, if we have time, I'll talk about the new HP VR headset, which has a ton of sensors I think might apply to some stuff we'll be talking about.
Sure. So let's save that for the Ross Neuro, because certainly one of the topics I was going to bring up was the multiple kind of physics engines that as well as how OpenAI Gym kind of can feature in here, and like again, like why why did OpenAI get Mujoko? Like,
Yeah.
why did they purchase that company, and what were they getting from it? Like, what was the real IP there, and of value? And you know, because it's still pretty remarkable that I mean, I believe that that software is still commercial. Like yeah. So anyway, love to talk about the physics simulators more. I brought up wanted to just bring up the book that I'm currently getting through, which is the author is still doing book tours, so you can catch him talking at this point. He was talking in our bookstore here in Palo Alto, or in the Bay Area. So David Eagleman talking about LiveWired. Because one of the things he talks about is that the brain operates where sensory systems are kind of like these modules that can be, with very small genetic changes, like an entire module can disappear, and as well as some really interesting other thoughts about why we dream in terms of keeping the visual system from being overtaken by other systems, and cool experiments where people get blindfolded and trying to live out a blind life for short periods of time, and then seeing the changes that take place where visual system starts to be used for tactile and auditory processing and things like that.
Question.
Sure. Well,
I'm sorry. I think I might have missed the name of the book.
I dropped links in the chat, and I didn't do this earlier, but now is a great time to have people who are new introduce themselves and tell us what brings you here.
Okay, I guess I'll start since I'm already on. Yeah, hey everybody. I'm John. Nice to meet you. I'm from the East Coast. I'm an undergrad student currently at RPI, up in the East Coast. Why I'm here right now? I've been really interested in doing a lot of BCI work. I was working with a professor last year to do research on signal processing. But that professor actually had to move recently, so I was trying to get more involved in the field on my own way, and that kind of led me here. I had a question that Morgan asked me to kind of share here, so I'm going to share it here. Yeah, let me find it. Yep. Okay, so basically the question goes around this: for an undergraduate sophomore, what is the best way to get BCI research experience? And I'm posing this question to you guys here if any of you guys want to hop in. But that's kind of for at least me personally, I'm still trying to figure out how to get research experience as in the BCI field without any sort of professor to help with.
I have a comment on that. What side do you want to be? Someone who participates in participating in studies can also help you get in. I actually went RIT over in Rochester, and I was part of a couple studies. No neurotech studies, but I do know since RPI also has a bit of a tech and medical group, they probably have studies locally that you can participate or even volunteer or help with if they need people who to be double blind people to present tests or stuff to people, and there should definitely be some stuff in your area for trying out some of the tech. There should be at least 1 or 2 labs on campus that will at least talk to you about using their lower level stuff. Maybe not a 256 channel highly amplified setup, but something like an 8 or 16 channel dev kit.
There could be.
Yeah. Like try to get the high end one.
Have we asked if there's a student club there? And if not, would you be?
I've done my research on this. My research on this has been like I'm not gonna say it's been the most thorough, but like from what I've seen, at least I researched the professors. None of them do research in it outside the one professor I found. The professor I found, by the way, if you're curious, his name is Sergio Paquito. If anyone knows his name, he doesn't. He had to leave. In terms of clubs, there are no clubs. I know that for a fact. On what you brought up. Sorry, I don't. Okay,
Ryan.
You want me to call you Pyconaut, or I'm not sure what to call you.
That's true, Ryan. If you're not gonna use your real name,
like I don't know what to call you here. Like
Pyconaut works.
Or it's Psychonaut.
Psychonaut.
Yeah, but
Psychonaut. Okay.
Yeah, I made that nickname about 18 years ago.
Oh, okay.
And it like I want to do something where it's hard to pronounce, but because it has psych in it, it actually works for this. But yeah, my name's Ryan.
Okay. It's okay if I call you Ryan, Mr. Ryan, Dr. Ryan.
Oh, Ryan. I am not a doctor.
Sorry.
Yeah. But you might want to reach out to like I know. So you're at Rensselaer in in Troy, right?
Yeah.
I'm trying to remember what place it like. My family's from that area, like from Schenectady. So I'm trying to think of what some of the research institutions. Like there's a couple big nanotech places out there I know, but try and think of any groups doing like nano stuff with neuro.
Have you checked though if there's an EEG group? Because I mean, we talk about BCI, and and there's good BCI stuff, but it's really a wide range. There's a wide range of kinds of BCI, right? And a lot of EEG labs would give you good research experience. Maybe FNIR. I'd also say neuroimaging groups because RPI's got to have a good fMRI center too.
They also have a micro robotics lab that is really amazing. Like one of the best micro robotics facilities in the country. And I don't remember if it's been years since I've been to RPI, but
okay. First off, by the way, thank you. But out of curiosity, like, okay, well, you know more about my own university than I do, which is okay. That's great. That's great. That's great.
Weird things at universities. I tour a lot of universities, and literally after the tour, walk down the sketchiest hallways to the biggest rooms that have nothing to do with anything, and ask, "Hey, what's happening over here?" Like our RPI and RIT both had these massive buildings that no one would go near, and they had such cool electronic labs and these hidden labs underground that so like
I do think this you could go exploring, but this non-invasive brain imaging and stimulation center, I mean, that really looks like an awesome place.
Said there.
The place that I put the link in for Center for Modeling, Simulation, and Imaging in Medicine, and then there's a place that does brain imaging and stimulation.
Oh wow!
And there's like EEG, transcranial, like TES. They're even doing TRNS.
And
they definitely have EEG. They're doing EEG, and they'll be doing like high high level EEG there, like high density research grade stuff. So there'll be people who know their shit.
Yeah. You're going to be able to find stuff pretty easily, and if you need researchers, I do know that like even though they're a couple hours away, I do know there's quite a lot at UOR, University of Rochester, because their medical facility has some of the gear they have there for medical imaging is just stupid. Like they have like some laser based imaging stuff for medical research that it was, at least a couple of years ago, the largest medical use laser in the world. And
there's a great language ERP researcher, University of Rochester. I'm trying to find his name. Irish guy. Anyway, you'll be able to get these links from us, John. I know you're on Slack, so that's awesome. I wanted to just quickly ask if Jaden could help us with one issue with EEG notebooks, and which is, so Kaushal has joined us, and not to put him on the spot, but you know, we're very lucky that we've got more Muse testers for EEG notebooks.
Oh, cool.
And well, Kaushal, remind people where you're from.
Okay. Hey guys, I'm like John. I'm also an undergrad. I'm a junior actually. I go to UC Davis, and I'm majoring in Causey and minoring in neuroscience. So yeah, that's my background. And currently, I work at an EEG lab with Steve Luck doing ERP research. And so that's kind of how I got into neurotech and EEGs and BCIs. And I started a neurotech chapter here at Davis. And so as part of that, we got the Muse, and we just started before COVID hit. So we're trying to pick back up, and our first project is to make a BCI controlled light bulb. And to do that, my first step is just trying to stream the data live from the Muse into like a Jupyter notebook, so I can do some entry-level processing. And that's kind of what we're having trouble with. So right now I have the dongle with me because I'm on a Mac. So I have the BLED 112 dongle, and Morgan, how do I describe the issue? Like what exactly is our issue?
Sure. And I can you know, like, I don't think this is going to surprise anybody. I mean, it's just that, like, we've been testing with OpenBCI, and so currently the instructions with Muse are just lacking that. Like, you still need to. I mean, with Muse, also not with Blue Muse, right? So if you've got Blue Muse, then it's kind of dealing with the connecting and the streaming start, right? And on a Mac, I wasn't quite sure if I should be pointing people to the old, you know, like the old, you know, Kyle's old Mac instructions maybe need a little bit of an update, but you know, certainly it's currently crashing out the viewer, or at least like we've managed to make it work again, just like using Muse LSL, but then it's not actually bringing up a viewer, and it would of course
using the V2 viewer.
Even in this case with the V2 viewer, right?
Yeah, we tried the V2 viewer, and we even installed one of those dependencies, right? But then what happened?
We had to add VisPy.
Yeah.
To get that viewer, which again, like, shouldn't be a big deal, and you know, we went through it, but the main thing was that, like, what I'd love is where can we point people to the current documentation that takes us through a Muse Connect that should work with the current notebooks.
For Mac specifically,
well, I mean, it should be the same as Linux.
Okay, then in that case, I don't think you need to do anything special. Once everything's installed, it should just.
So I mean, I you know, Kushal was good to have me sit and watch what he's doing, and like he's doing everything that we say, getting up to, you know, running an N170, but it's not connect. You know, it's not asking, or, you know, it's not listing or asking for the device, even though, like, we've specified device equals Muse, you know, Muse 2016.
That's one issue, and then a secondary issue was just that regardless of, even if it connected properly hypothetically, I think there's just some errors in the example code that's there on the EEG notebook documentation. Right, Morgan, where we saw that one of you have to include.
Session isn't listed again. Like, session's not in one of the function arguments. Yeah. It's definitely there in the.
I thought I
so guys, like two comments. One is put these in issues.
Sure. Yeah, because I don't really know exactly what
sure.
Like, if screenshots and stuff would really help.
Sure.
Screenshots. You know, copy paste text if you have error stuff that can kind of format all right in the markdown. And I was going to say, oh yeah, so try and figure out, is this a streaming thing, or is this is this a Muse LSL thing, or is this an EEG notebooks thing? So can you do Muse LSL record duration 10 and get a CSV file from that, or not? That's the first question.
You could check, Kushal.
So I was able, if I just open my terminal and if I just do Muse LSL list and Muse LSL stream, it works. I did record, and then I tried to do a duration, but for some reason maybe I wasn't doing it right, that part. But like because I wasn't getting a file, and I clicked and I tried to view it, and I wouldn't be able to view anything, but it was recording. I just didn't know how to like end it or store it or do anything with it, but it told me it was recording.
Okay, so there's the command line arguments, and you know, it's something, I think it's Muse LSL record -D, and then you 10 or something.
Yeah, it was something like
10
that.
seconds. So if that doesn't, and then file name. So if that isn't producing a file name, then that's definitely like a major error. If that is producing file name, and then the problem is down the line, then there's different type of things. So let's try and figure that out first.
Okay, I'm gonna retry it like right now, and then we can see.
Sure.
Yeah, and I'm not on my Linux drive right now, so I can't test it myself at the moment.
Morgan, yesterday when we were creating the environment, was that for EEG notebooks, or I forget why we exactly went through the steps of doing that?
Well, that was specifically so that we could be sure, you know, of all the dependencies that were in it, you know, that you had like the right base to start with. Yeah, but we were, in terms of the EEG notebooks, we were using the 2.0, or I mean, sorry, the 0.2, right? And you know, that's where I've definitely, and we'll make some issues. But if we just follow like the easy startup kind of instructions, then we're not going to get the same behavior when you put in Muse as you get with, you know, Cyton and stuff.
Okay.
And, yeah, and I wasn't sure, you know, like partly I wasn't sure whether it was good to whether it was good to, at this point, how much we wanted to test with that. And okay.
Can you move it over so I can see the right side of the terminal window as well?
Like that?
Okay. Yeah, so it looks like the issue does happen to be with Muse LSL.
Well, it detected it, and now it's streaming. Or
which I found disturbing too, where it was like it wouldn't, and then it would, and
the documentation literally says to do it multiple times. So yeah, see, it connected, and now it's streaming, and then
so maybe it's, if the documentation says to do it multiple times, it's possible that the same thing might need to happen for EEG notebooks for it to catch on and stream as well. Because it seems like it's kind of like finicky with Muse LSL, whether or not it's actually going to hold on to the Muse. And so if that's happening with Muse LSL, it'll probably need to be replicated in EEG notebooks as well, I assume.
Yeah, well, I think it is using, like, it's using the Muse LSL connection protocol, and yeah, I think it does do a kind of check and reconnect thing. You told this to run for 10. Where are you? If you Muse LSL stream, this isn't record though. Can you do?
It's not record.
Muse
LSL
record
and
cancel that. Control C, and then you need to
cancel this one first.
Kill that first.
Cancel this first. Okay.
Yeah. So Control C.
Control C.
And you're not using the notebook that we set up.
No, this is from my base. This is
okay. Just checking.
Okay, so now.
All right, so you need to have two processes, right? Okay, actually, sorry about this. You need both. You need to do the stream in one terminal, and then you need to open up another terminal and do Muse LSL record.
Oh, okay.
And by the way, if you create an environment, you don't have the environment activated at the moment.
Yeah, that's what I.
So do you want me to run it in the environment or not?
Well, yeah. It's then we know which versions you got, and I mean, because you use the requirements _test thing.
So should I do conda activate MB Mac?
Yeah.
So I should do stream in one terminal window and record in the other?
Yeah.
Okay, let me share my screen again with all of this windows instead of just one application.
I'm just checking.
Okay.
Is Ian joined us yet?
So I should activate the environment in the second window too, right? Like it should run in the same. Okay. So it's streaming. So it's streaming in the left one, and then over here I'm going to do Muse.
Good. Okay. So now do Muse LSL, do record, and then -D 10 at -F test.csv.
-D 10 and then space like that.
Yeah. I can't see because, but drag it to the left so I can see that terminal. Right.
Can you see this one right here?
No, drag it over to the left. That's better. Okay, yeah, so do -F and then test.csv. Okay, give that a go.
Is that what it says when it thinks it's dropped a packet?
Yeah, it happens sometimes. Can't find
So what is a marker stream?
The marker stream is what would come from if you were running a PsychoPy, visual experiment, for example.
Those are your event codes. Is that what they are?
Exactly. Yeah, the triggers basically. So you got an issue there. What's the issue? Can you
directory?
Pull it up a bit.
No such file or directory.
What is it?
That's weird.
Now, would it automatically be going into .eeg notebook?
Yeah. Can you give it a full path? So can you make it -F and then
just up
like
should I copy this whole thing?
$pwd/test.csv. Do the same as you did before, but just do $pwd/test.csv.
pwd.
Now, slash, so / after the pwd and no dot, but and then put a $$ in front of the pwd.
Oh, $.
Yeah. Bash foo here.
Okay. So like, does that look good?
I'm assuming that's going to work on a Mac. I don't have Mac.
It should. Yeah, he's running Z Shell.
Is it still streaming? So it's correct in saying that it can't find a marker stream, right?
Right.
Yeah, that doesn't matter. Read only file system. Okay, so whatever I did just then was wrong. Sorry about that. But can you just do something? Do /temp / just stick. What I want to do is give a full file path for the file. So just somewhere where you know it's going to go, like /tmp. It's got to be a folder. Yeah, DTMP.
Sorry, I'm not understanding. Do you want me to put it in any folder that I have? Can I put it in downloads? Is that?
Well, we need a full path from root. So from like /. So that's why
like users, control. Do you want all of that?
Put it in temp. Temp is it TMP.
TMP is a folder that exists, but it's just without the E.
Oh, okay.
Yeah, don't worry about the E. Yeah, there you go. /, and then test CSV. Yeah.
Okay. Do you need a $sign this time or no?
No. This is to try and avoid that. Yeah.
Okay. Don't know what went wrong there, but how do I put this? Pride myself in not knowing anything about how to use a Mac.
It's just BSD Unix.
All right, but why did that not work?
I'm not. I mean, is it a Muse LSL thing or?
No, it's Bash thing. I don't know. Maybe.
Again, like he's running Z Shell, but
so it did work.
Hey. Woo! Okay.
So when it says it wrote the file, is it? Oh, when I specified the duration, was it 10 milliseconds? Is that what?
That's right. So just do cat temp test.csv.
Yeah.
What does the cat command do?
It's gonna just print it out.
Prints it to screen.
No such file.
No, do the full path again. The /tmp/test. Yeah, CSV, and then you can just tab. Yeah. Yeah.
Okay. So that's what your files look like. The problem there was basically everything's working fine for you. At least at this point, from what we've looked at. In order to do a simple recording, this is all you need to do. You just need to have a stream running and then run the record command. And in this case as well, you also need to specify a full file path. And you can do a lot with that already. Adding in, the full like EEG notebooks compatibility is more stuff, but you definitely have like the basic ingredients there.
How do I stream this? How do I stream it live instead of recording it? If I'm trying to do something.
So we can try the viewer now. So if you, I think you still have the stream going. So do MuseLSL view, and then we'll use the version 2. Yeah, -v2.
The double dash or one?
It's single -v and then just just V and then 2.
Okay.
V2, yeah. And this one, like normally this is the better one. But when you say a live stream, you mean a live visualized stream, or do you mean you want to access it in real time?
Well, that's
both. Basic. I mean, prefer like visualizing is good, but also like if I'm trying to turn on and off a light bulb, I would like it to be in real time.
So in that case, you're going to have to look into accessing the LSL stream real time, but you do have a live stream. It's there on the stream. So if you once you know when you find out how to kind of pull that data with the application that you want to use, then the data is there for you when you have the stream running.
Okay. So what is it saying here?
Okay, can we try the first one?
Too, right?
Right.
Okay.
Just try without the V2.
I think Morgan and I encountered the same error message last time.
Yeah, we did. We definitely saw that viewer problem. Yeah. That could be
Canvas. Runtime error dictionary keys change during iteration. Like I would search for that. I would search that runtime error thing. Google that and see.
Did you guys see that thing pop up and then go away?
Yeah, I think this might actually be something that that Kyle does fix with a. If you go back to the V1 documentation, the instructions for Mac, I think there's something where you need to change the matplotlib backend to like TKAG. I think this is actually relating to that problem, and anyway, this is awesome. It's coming up at 7, and I want to be able to switch over, but Kashal, we can follow up in terms of issues, and I mean this is good stuff to put into the new documentation, in the sense that like there maybe still are some Mac specific things that need to be because if I don't have that.
Yeah, the viewer definitely, I want that to work.
It's the
so currently, like, how are other people doing stuff with the Muse? I just don't seem, when I search things up, I don't seem to find a lot of like projects. Like there are a lot of forums that go in depth, but they're like a little old, so I don't know if a lot of things have changed so far, and I don't know if anyone else is actively running into the same problem as I am. Because the Slack doesn't really have anything about that.
Well, we're doing a lot of work with at the moment, a lot of development work on this on this project. So there's activities here. You've probably seen Olaf Krigelsson's stuff if you've done some Googling. He's done a lot kind of going back a few years, including he's published a lot. So definitely check out his stuff. I think tools-wise, he's actually kind of switching over to using LSL like they were using MATLAB before. I had a discussion with them a few months ago, and they seem to be kind of in flux a bit with streaming details and so on. But those guys do cool stuff. And Kyle Mathewson, I mean, he's been doing a lot of cool stuff, including like if you look in the EEG Notebooks examples folder, there's a data set from him that he recorded in his class that's got about 80 subjects. There's two kind of terms. So there's two data sets that are like this queuing task that they ran in his classroom, and it's a pretty cool like visual queuing, visual spatial attention task, and that's it's a really good cool data set. The documentation still needs a little bit of tidying up, but that's a good place to look for like that's the most sophisticated experiment that I've seen done with this device in terms of like a standard cognitive neuroscience experiment, because it's got like visual cueing, it's got reaction times, it's got spatial stuff, etc.
Got it.
So, hey, Kaushal, I dropped in what could be a quick thing to try and check out. We need to switch over right now, but if you just put in this Echo backend,
where should I put that?
You just drop that in your terminal, and it should change. Yeah, and then try the then just up arrow and twice.
No.
Yeah, try that again.
So if this is currently not working now, how would you recommend I try to work around it to get this to be able to access my stream in real time?
Well, it depends what you mean by access. You mean visualize it, or do you mean
no, like maybe process? Like I want to, in theory, implement like an alpha band threshold so that if my eyes are closed and there's a lot of alpha activity, I'll turn the light off, and if there isn't, then I'll turn the light off. That's kind of what I'm thinking.
Yeah. So for that, there's not anything in the kind of the EEG Notebooks code that does real time. Anything that's real time, it's all kind of offline. What you're going to need to look into is how to like whatever the program that you're interested in doing, like the real time light bulb control, for example. Like how are you establishing that packet updating or whatever? And the thing that you're going to need to do a bit of research on is how to pull numbers from the LSL stream. And there is like code that like Python code that does that in both Muse LSL and EEG Notebooks. So like between those two libraries, you can see how the stream is being accessed, but you're going to have to do a little bit of extra stuff to access it in real time in with the application that you're doing. But actually, the viewer is going to be the best reference point for that, because that's doing a real time updating. So I guess it would be like just firstly try and get the viewer working. You can definitely get there. Just keep at it. You'll get there. Google the errors, etc. Keep asking us questions on the forum. Then once you've got the viewer working, I would say just like open up the viewer code and find the bit that does that real time update, and then just stick that into what your application is.
So what is the error that I'm getting? Should I Google segmentation fault 11? Is that my error?
I don't think that's going to be the
try the V2 one. Error, it sounded like a little bit more plausible error you had.
Try that again. and then we need to switch over.
Yeah. Sorry about that.
Okay.
Last try.
Because this was at least there was a problem before with the Mac OS X versus TKAG backend.
Okay, so you got a VisPy compatibility error warning worth noting.
Dictionary.
You got that there. So basically, I would Google that error message, runtime error, dictionary keys changed during iteration, and I would look into this VisPy Matplotlib compatibility issue and maybe downgrade your Matplotlib version to 2.1 or 2.15 or something, and try again.
Okay, I'll look into that. And in what forum should I post this on? Like if to get issue, like is there an EG Notebooks forum or?
Well, on the issues, on the EG Notebooks issues page, we'll help you with it.
Got it.
Okay.
Thank you.
Okay, so definitely follow up. Okay, Kaushal. And
yeah,
and because also a lot of people ask about that kind of application where it's just like they want to take their Muse stream and do a simple operation, which is different than kind of like the ERP studies that we have with EEG notebooks. But I'd love to know what people have as options for doing those kinds of things. And I'm still curious about what kind of light bulbs you're going to control, and how you do that, like whether that would be the Philips Hue or something. So switching over. Sorry, Ian. We're a little we're not always on schedule. But I want to welcome Ian Mcintyre here, joining us from Berkeley, I believe.
That's right. Yeah.
Okay. And so, can I just turn it over to you for?
You sure can.
For intros and presentation.
Hello, everyone. I can see that there's maybe about 20 something of us on the call here today. I'd be interested to know where everyone else is and stuff like that. But just a quick introduction to me and why I'm talking today. My name is Ian. I'm the CEO of a company that's based here right next to UC Berkeley. We originally, if you can tell from my accent, I'm from Australia. We were all from Australia. We were based in Western Australia. We all came out of a university called the University of Western Australia, my co-founders and I. And had always been fascinated by nootropics and brain stimulation and brain-computer interface in general. We decided to start a company over there about 4.5 years ago, and have now turned it into kind of a going concern of a company over here in Berkeley. It's been a couple of years in the running, and we've done a lot of things. We've done some of the stuff that looked like you guys were just doing on the call just then, using EEG signals and other biometric signals to power algorithms for control of devices and measuring cognitive performance and things like that. But the main thing we've always focused on in my company, which is called HUM, which we don't tell most people, but HUM stands for Human Universal Mind Machines, which is kind of the biggest, most audacious sounding name that we could come up with. We do brain stimulation. Particularly what I'm doing right now is the montage of our first device, which looks something like a little bit of a messy desk today. Let me have a look. Which is a patch that basically sits in just over the prefrontal cortex. It's doing TACS, transcranial AC stimulation, and it's boosting a signal in the prefrontal cortex, but also just throughout the brain, called the theta rhythm, which is between 4 and 8 hertz frequency. I'm sure that everyone here is pretty familiar with brainwaves. I won't go too far into the basics, but we can talk about the specifics, and we've done a lot of research. I've got a couple of co-founders, and we've done some collaboration with existing and previous research. So I'm here to tell you a little bit about what we do and the method behind it and what we're aiming to do in the future, and also just meet everyone and get everyone's questions and tell you a little bit about TACS and TAES in general, if you don't already know a lot about it. So yeah, my name's Ian. Thank you for having me here. It's my first time coming to the NeurotechX Hacks Night, but I've known about NeurotechX for many years. I've met Yannick, the guy who I think founded it. I've met him at many of the neuro conferences over the years. Yeah, okay. Did you have anything you wanted me to start with, or should I just get started telling everyone a little bit about how we figured out what we do and what we do?
Yeah, no, I'm happy to get the presentation, and then, or give us what you would tell people, and we will generate questions.
Sure. At some point, it may be good for me to share the screen.
Yeah, it's the bottom. So the bottom left corner.
Oh yeah.
The middle button there. Yeah.
Perfect. Cool.
You can select a window or the whole screen.
Yeah. Cool. I'll just kind of. I think that everyone's probably able to process quite a bit of data at once, so I'll kind of show around our website a little bit.
Yeah. I mean, I advertised your white paper, which I thought was a really nice introduction for people, as well as some of the research work that you've done already.
Oh, great! So everyone's already kind of seen that stuff. Yeah. So our website is at thinkharm.com. Obviously, we're introducing this technology and the science to the public, so it's kind of it's written for the general public, but you can dive in and get some of the more specific, deep details. We have a good blog. We have a bit of an FAQ, which links to some of the more detailed safety-related information. But I think the stuff that most people will be interested in is just getting a look at the product, which is this patch here. I've got a couple of prototypes here in front of me as well. Just something like that. We've got a couple more in the office too that I didn't bring home. And I'm also wearing the research version that we use in lab studies. It's a little tiny patch that you stick on your forehead, puts in 6 Hertz AC, modulated theta. So it's just just simply a battery at the moment with 2 electrodes that stick onto the forehead and pulse a very tiny AC current at about 1.5 milliamps. It does adjust the current a little bit depending on adjust the voltage a little bit depending on the impedance of someone's skin. So it is doing a tiny bit of measurement. It's a very simple device for now. We're not doing any of the biometric cognitive stuff. Biometric algorithmic stuff. Looking at measuring performance and timing it with the stimulation yet in our first device. That is the stuff that we're doing in the longer term, though, and I'm coming here just to point to our white paper, which I think is a fantastic read.
Yeah.
I hope everyone... Oh, you can't see it. It's the way I've shared the screen, but if you click on that,
yeah,
it's like a 30 or 40 page document where you can look. So feel free to either look through that and give me questions as we go along, or just follow along. So basically, my co-founders, of which I had 3, and I, in Western Australia about 7 or 8 years ago, got involved in this research just as one of us was a medical doctor who was conducting some research using transcranial magnetic stimulation, which something a lot of people here may be familiar with, has been around for quite a while as an FDA-approved treatment for depression, things like this. They were actually investigating in that study that my co-founder was running the ability to transcranial magnetic stimulation to help people with spinal cord injuries, which excitingly has shown some fruit recently, right? Like last year, I believe the first 2 people who had at least partial paralysis were enabled to walk again temporarily as a result of transcranial magnetic stimulation, i.e. magnets placed against the skin. But to my co-founders and I, it was just an introduction to the technology, coming into a lab and having a powerful electromagnet put on your skin, across your head, and stimulating you in a way that made your arms and legs move all around. I myself was a law student and studying physics as well. I had 2 of my co-founders were engineers, and the guy who was running that study was a doctor. Over the course of the about first 3 or 4 years of investigating this technology, going from R-TDCS and the other kind of like little communities where people experiment with this technology, and looking at some of the FDA-approved devices on the market and non-FDA-approved devices that were pushing into the market in the consumer space too, became really excited by, obviously this is a subset of the much broader industry of brain-computer interface. Really exciting companies working on the other side of the equation than stimulation, companies like Muse with the meditation device, and had some good science done with that device too. Emotive, and Neurable, a whole bunch of other companies working on cool stuff here. And excited by the convergence of that stuff with the stimulation stuff into a closed loop, as well as, you know, other parallel technologies like VR, which when you put together closed loop brain computer interface with VR, you can start to see all kinds of, you know, divergent possibilities for cool devices and outcomes. And that was what inspired us. We were inspired because we had just come out of college, and we wanted to learn faster. And so that's why we focused on this montage that you see in front of us. We were reading a lot of the latest research. Obviously, TDCS, TMS had been around for a long time, the DC and the magnetic version of what we do. But we're particularly excited by some of the stuff using TACS, the brain, you know, kind of analogous to an electric circuit, and AC, as much as it's far more complicated than that. Being able to tune particular brain waves and being able to use the characteristics of AC waves in general through the placement of electrodes for constructive and destructive interference, for wave shaping and things like that. We were really excited by the potential of the TACS stuff. And so we spent a couple of years just at a non-scientific level to start with, just, you know, buying and experimenting with open source stuff as well as previous devices. A big shout out to the Open BCI folks who helped us in the early stages, getting set up a concentration lab where we were from, doing some basic experimentation, building, you know, 3D printed headsets where we could put electrodes on the skin and try and measure signals correlating to concentration. Not that dissimilar to what a couple other people had done before us, but it was our start. But over time, became more focused on building our own device. We were really focused on this long-term idea, which we've now patented, and other people have patented various versions of too, just the closed loop combination of EEG and transcranial AC stimulation as a way of improving specific cognitive functions. Obviously interested in the long term in kind of this brain equalizer for everyone, where whether you're healthy or sick, you can get a desired outcome. But in the short term, people like us, people who wanted to learn faster, and the extension of those people who are older than us, people who are, you know, nearing that stage in life where working memory is deteriorating, it's just naturally deteriorating over the course of your lives, and want to learn faster. And so all of that is just introduced the reasoning for why we've ended up doing what we're doing.
Ian, sorry to interrupt.
Go ahead, ask as many questions.
I don't know if anyone else is seeing the screen. I'm not seeing the screen.
Oh, yeah.
Were you intending to share screen?
No, I stopped sharing it a little while. I'll show a couple more things.
Okay, sorry. Yeah, just checking. Sorry, I heard some clicking, and I thought maybe that was you.
Oh no, I don't know.
Sorry,
that's okay.
Carry on.
Yeah, everyone, just feel free to interrupt and ask questions. This is, from my perspective, a very informal chat.
So just to check, did you say the concentration lab?
Yeah, we set up like a little informal lab ourselves in Western Australia with a couple of researchers from the University of Western Australia, just overseeing us using pre-existing devices and building our own to try and do just, you know, simple tasks with EEG. Nothing fancier than anything that you guys would be experimenting with in your spare time, just back in like 2014.
And I assume somewhat focused on working memory again. Like,
we at that time were not particularly focused on working memory. Yeah, we were more focused on kind of a broader value prop of like, could we help people focus? And we're actually mainly working with university students. You know, this is as we were kind of getting towards the graduation point for our various degrees. And so we're all looking at, you know, people like us and just helping them with a device that could help with concentration. It was a very informal start. We weren't a company. We weren't a formal research lab. We were just a couple of guys basically doing what NeurotechX does, not having yet understood that NeurotechX exists.
Sure. And when you said, or certainly a question that has been raised recently on Slack, you know, like what systems do you think are ones that people can try out? And yeah, did you ever build your own? I mean, in the sense, obviously you have now, but like back then, did you try building your own, or did you get you know, like a cranial stimulator and repurpose it?
Yeah, we did a whole bunch of stuff. We were playing around with this stuff for years before it was a company, And even when we were a company, we've had a couple of different iterations. The very first things that we did, like anyone does, we built our own little TDCS circuit with a 9-volt battery and just a little circuit between it to regulate the current. Pretty sketchy, but it's what everyone does.
Yeah.
And then kind of iterated on that, actually collaborated with a couple of other people here in the States and in Europe on just like little tools that we built ourselves, little circuits to do AC, DC. We even built an FNIRS device, an EEG ourselves. We were really just hacking at that point, measuring concentration, trying to test it in little like informal trials with 20 or 30 students at a time.
And is the let me see which window I have here. Is concentration, what's the Causey block tapping tests?
Yeah. Causey block tapping test is specifically for working memory.
Okay.
We actually started with this like large cognitive battery of several different tests. I think
was not to keep your flow going, but what would be concentration and then what would be working memory?
Yeah, we've done digit span and attention tests. The stuff that we just pulled directly out of neuroscience laboratories.
Yeah.
So the digit span, just remembering a sequence of numbers in order, and then trying to hold that amount, those numbers in order for a period of time. The working memory tests are like the Causey block tests, are more manipulative, where you get presented a randomized sequence of information, and then you have to remember it in a randomized order or backwards, those kinds of things, or the name's escaping me, dual MBAC, and various things like that. The white paper that we've got online is about what Hum does now. So fast forward several years of work through. We, in the meantime, for a little while, we're working with things like pro esports teams in LA, which is a fascinating period of our company, where we were doing heart rate variability combined with metrics we were pulling out of eye tracking data, combined with EEG, combined with performance data from games to give people an algorithm for mental performance, concentration, working memory, and all of these things, as well as doing stimulation. And various versions of that. It's been a long journey. We at one point were doing it for like cognitive athletes, that we called them, but basically just like accountants and lawyers and things like that.
Okay.
At one point, we were just doing it on all kinds of startup people. So fast forward through this long period of experimentation over several years, UC Berkeley offered to invest in us through the Skydeck program for the latest version of our idea at that time, which was this working memory stimulation product, which is a consumer product, not a medical device, but has really interesting medical research applications and opportunities in the future, and even already some decent indications in early stage research in other people's labs. And that device was the Prefrontal Cortex Stimulator. It was all based around a study that we did using the Causey block test. Maybe I'll show a video of that. It was fundamentally just replicating some existing research. Just pulling up this test. Fundamentally, we were just replicating some existing research using this method, the F3 and F4 stimulation at 6 Hertz, showing an improvement in working memory, behaviorally being able to be measured for a duration after the stimulation and during. But we were putting it into a device with a closed loop with some software that went along with it. And we did a couple of little trials. Our first one was at the University of Western Australia, but it wasn't formally published. And our second was in 2018 at the Skydeck Accelerator. Hold up, I'll just figure out how to share my screen.
Sure.
There we go. Oh, Inception.
Yeah.
Yeah, so if those who aren't familiar with it, this is the Causey block test. I think this is the forward Causey block test. So this is flashing in a randomized order, a series of blocks and it starts with flashing one block at you. You click that block, it starts with flashing, then it goes to 2, then it goes to 3. And every time it's randomizing the placement of these blue dots, it's randomizing the order at which the blue dots are flashing yellow, like that. So and then you're clicking it. Now the difference between this one and the reverse one is that this one flashes a sequence to you, and then you are asked to click it in exact replication, like 1, 2, 3.
But it's essentially it's like that old toy. I mean, I'm probably dating myself, but like Simon, I think is.
I had the same toy.
Okay.
Yeah, it was Simon. Simon Says.
Yeah, I mean, it's got like 4 positions, I think, and it
red, blue, yellow, green, and each one had a tone as well. So some people did it by color, some people did it by order of lights, and some people did it by audio cues. It was a lot simpler since it wasn't literally moving.
No. But now I've got a better mental image for what the Causey block test is.
Yeah.
Did you use Pebble for this?
Yeah, we did actually.
Okay. And could you describe Pebble for people who aren't familiar with it?
Pebble's a frustrating but fun tool, which you can use to do a couple of different cognitive batteries. We basically copy pasted the code for the test that we used, which looks exactly like this.
Is it open source, or is it freeware, or
I think it's free for research purposes and non-commercial purposes.
Gotcha.
I can't recall if it's fully open source.
Okay.
But yeah. The reverse version of this is really frustrating. I don't actually think I've played the Simon Says game, but just imagine you've got 10 blocks. It flashes 10 blocks to you. You've got to remember them in reverse order really quickly.
Yeah,
it's a real pain in the ass. What it's doing though is it's every test, like any mathematical model or economic model, is just an approximation to something that's going on that's quite complicated in the brain, right? But what we think this is measuring and seems to be quite well standardized for is working memory, particularly visual spatial working memory, the ability of your brain to kind of hold in a RAM style effect, the placement, orientation, order, and sequence of a variety of information. We believe that this kind of extends the effect that we're measuring actually extends beyond that very specific test, the Pebble test, but don't have a huge amount more data than the Pebble test, and that's what our white paper is written around. We have also got, thankfully, we didn't do this just on a gut instinct. We did this actually coming out of like an incremental process of testing the various methods of stimulation that we're interested in against standardized tests on things like concentration and stuff.
Yeah.
But we also based it on particularly some studies at UCSF at the Neuroscape lab, where they were doing a very similar test.
So Adam Ghazali's lab.
Ghazali's lab.
Cool.
Yeah. The guy that we work with in particular there is Dr. Ted Zanto.
Sure.
Zanto's the head of neurosciences and associate professor of neurology. But his particular interest is in the non-invasive neurostim stuff.
Definitely. Yeah. So
to summarize just a tiny bit, what I'm wearing now is what our device does. Little sticky pads, back and forth, 6 hertz, causing this kind of entrainment effect, we call it, in the prefrontal cortex. It seems to ripple throughout. You can measure it instantaneously in EEG. And like is shown in our white paper, which again is just a replication paper, you can actually measure it behaviorally, having an effect on working memory capacity. Within a couple of minutes, we measure the full effect that we seem to be able to measure, which seems to be something like a 20% improvement in the capacity of working memory, the amount of information or the number of digits that you can hold there in this test. And then it seems to sustain for a duration after the stimulation too. There do also seem to be some significant variations between individuals, and there are also other behaviorally conflicting, conflicting inputs behaviorally, such as stress, tiredness, or fatigue, caffeine, and things like that. These things can have an impact day to day. So there's a lot of variation. But we do see that against a placebo, which is the same setup, but with a 1 hertz stimulation, that it does seem to improve pretty reliably people in the working memory test against the placebo by 20%. So the people who to get the fake stimulation also trying to go up a tiny bit, not because we think the stimulation, but rather because just the placebo effect. But when you put them on this really hard game, you measure out our stimulation method against the placebo, you see this 20% improvement. And it's just from the electrical entrainment of neurons at 6 hertz, basically boosting the theta frequency overall. And without saying that we know all of the answers, we think it's causing an effect that's just allowing the brain to process and hold that information easier as a result of that brainwave being pronounced.
Is there a reason why you chose the temporal lobe, or like the temples, as the placement for the electrodes, or is it just because, like, I believe that attention and short-term memory are sort of distributed throughout the brain, right?
Yeah, we believe they're distributed too, and that's a really good question. We don't think so. The fundamental, sorry, let me fix this. The fundamental reason for the placement of our electrodes comes from actually more from a convenience perspective and just replicating existing data. It's really simple to get this little patch on the forehead if you can place on a place without hair. Also, there were a couple of other people's studies who had done the exact placement that we're using. Perhaps a little tiny bit higher, as you'll read in our white paper. We're more looking at this FP3, FP4, which just lets you sit underneath the forehead, the hairline. But the studies are particularly looking at F3, F4. When you model it, though, what you see is that you're causing an amount of electricity to get down into the prefrontal cortex, and measuring overall EEG with multiple electrode placement, you're actually able to see overall across the brain entrainment of theta, so an increase in the size, the amplitude of the theta wave between 4 and 8 hertz. So it's not, we think, just having an effect on that part of the brain. It's having an effect on that part of the brain, which is particularly important for the behavioral effect that we're measuring, but then it's actually working throughout. And if you want to get a little bit deeper into the white paper, we dive into, and that's what I'm just trying to share right now, we dive into some of the hypotheses we have for why it's working that way. Gamma theta entrainment is a really interesting one. I don't know if anyone is familiar with this study that was done last year at the Boston University lab, where they were doing frontal and parietal stimulation at the same time and putting them in phase and out of phase. And what they found is that when they put it in phase, so back here, the current was being modulated at the same frequency phase as it was at the frontal cortex, you're actually seeing working memory improve substantially. But when they put it out of phase, it was getting worse. So we know it's a whole brain effect, but we're particularly interested in stimulating this prefrontal cortex. And I think the simple answer to why people started investigating this placement beyond just the ease is that it seems like theta actually really changes quite a lot when you're concentrating in the prefrontal cortex. There are other effects like that you can measure, like the phase difference between frontal parietal areas, but this was just one place where theta seemed to be strongly correlated to behavioral improvement and concentration, and so that's why we tested it. We were particularly interested in this part of the brain here. I hope you can see my mouse. The frontal midline theta.
Yeah. And as you know, some of your references, I mean, like that's Juan Yu's work there with Ted Zanto. So.
Could I ask a question on the device?
Absolutely.
I think you were saying that you record EEG as well. Are you actually kind of closed loop phase locking the stimulation to
not yet
a measured EEG rhythm?
Yeah, not yet. Something that we've put some interesting ideas about how to do in patent is exactly that, phase locking, not just phase locking, but frequency locking the stimulation. Our company is particularly interested in the ability to measure peak theta and other characteristics like that in individuals that we could then use to customize stimulation. And I mean temporally, like at any moment, to customize the stimulation to a person, but also across different individuals. There are differences in things like the amount of cerebral spinal fluid that's built up in a person as they age. So a 60-year-old typically has a lot more than a 20-year-old, but one 60-year-old may have a lot more or less than another 60-year-old. So there are a whole bunch of mechanical, electrical, and much more complicated brain effects, like variances between individuals who have ADHD in the way that their theta response looks when they're measured across different tasks. And that's where that idea of the brain equalizer in the long term comes from. But the very first device that we've made is incredibly simple. It's just harnessing the fact that we can measure a pretty reliable improvement across a broad set of healthy population with the very simple theta modulation of the prefrontal cortex across the midline. So no EEG in this first device, although we do it in the lab, but definitely something we're interested in introducing in future products.
Yeah,
go on.
Go ahead.
I have a follow-up question to the device. Could you go over why you chose TACS, or I assume, based on the white paper, I'm assuming it's TACS versus TCDS and TMS?
Yeah, so we're particularly interested in TACS for a couple of scientific reasons and non-scientific reasons, or maybe just less defined scientific reasons. Scientifically, we're interested in TACS because we were interested in this specific effect that we were trying to cause to come about, the improvement of working memory, and that had been measured with this method of stimulation exactly, and so we're just replicating that. Also, scientifically, we think there's a lot of opportunity for things like wave guiding through constructive and destructive interference, through entrainment rather than just direct forcing neurons to fire like you are when you're doing TDCS, or just encouraging them to fire when you're doing TDCS, or forcing them to fire with TMS. But kind of non-scientifically, or rather just less defined, we think there's just more potential with the AC. We're yet to really prove it, and we know a couple of labs that are looking at it, but we think that being able to talk to the brain in AC, basically being able to put information in this AC waves, shaped and formed in different ways with different electrode placements, just gives us a lot more potential to do different things than the DC and the AC, for the reasons that I've said. It will require a lot of incremental study on a large population to prove that.
What is the sorry, I'm just trying to skim the white paper as fast as I can, but it seems like what you're doing is you're alternating the pulsing from one temple to the other. Does the pulse actually go through, does it cross hemispheres? Is it the case that the current is going directly from one electrode to the other, or is it just dispersing, or is it rather that you're just alternating, affecting one hemisphere versus another?
It's a great question. The answer that we've modeled is that the current is indeed going into the brain and through the skin. And we're putting in about 1.5 milliamps. Where are we in this white paper?
Yeah, I know you did some SimNibs modeling, didn't you?
We did, yeah. I think we used Roast as well. So we do think, and we haven't, cracked the skull open and put the ECOG in to double test, but we've had other people do MRI and things on the effect of TACS, and do believe that it is, yes, going through the skin into the brain and out to the other electrodes, so the current is passing through. It is, though, passing through the skin a lot too. You can feel it. You can also see visible artifacts in which we call phosphenes going through the retina, flashing, where the current is actually going down. So it's kind of very broadly being dispersed across the full forehead, which is one of the things that in the future would be interesting to be able to tune better. And I talk about the wave shaping and stuff, being able to be more precise, because we are limited by the fact that we are going through the skin. It's a very poorly conductive but interesting physical medium where there's sweat and other things going on, different shapes of heads, and the skull and cerebral spinal fluid on top of the brain too. it's one of the bad things about TACS or just TES in general, that it's so imprecise. But you don't have to have brain surgery, so that helps.
That's always a good thing. Is it possible? Oh, sorry. I feel like I just keep cutting you off, Morgan.
Keep coming.
Good.
All right. My last question. I'm sorry. Is it possible to instead induce the same effect with alternating TMS? Because with a magnetic field, you don't have this type of, or you have much less of a dispersive effect across the skin.
I actually haven't done a lot of work with TMS myself. Funnily enough, you're getting the business co-founder on the call rather than the medical scientific co-founders. But my understanding of the answer of why we're not doing TMS is that it's just really difficult to generate the currents. You need a big bulky device and an electromagnet. So that's kind of impractical. It tends to be more something that you're rolling around. It's quite difficult to get it to be precise enough. When I say that the AC, the current wash, is a bad thing, it's also a good thing because we're causing an entrainment effect, and we think that entrainment effect is having the effect. I think the shaping of the magnetic field would be a little bit harder, but I wouldn't be able to give you a precise answer on what the difference.
No, I think that's a good answer. It's more precise, and you also don't have to strap a giant electromagnet to your forehead. So that's a pretty good answer.
Easier, cheaper.
In terms of the question about the oscillations, though, yeah, like that's what the main clinical uses of TMS and also things like memory modulation, etc. They're typically you've got either somewhere between a 1 hertz and a 10 hertz rhythmic pulse that you're applying for 15 minutes, 30 minutes, something like that. Or theta burst stimulation, for example, which is like gamma frequency bursts on a theta modulated carrier pulse. And that's all those memory and clinical things with TMS, they're all rhythmic stimulation, like more like TACS than TTCS.
It's good to be on a call with people who know more than me. Yeah. Does anyone have any questions or interest about stuff beyond the science, or should I just keep talking about the science? Because
I have a quick question. Sorry, Ryan, go ahead.
This is really interesting for me because I have a very weird set of memory issues. Like I have really good short and long-term memory and absolutely abysmal working memory in certain categories. Like I cannot learn or memorize anything that uses written stuff. I cannot learn language, I cannot program, but if it's visual in a different way, like 3-dimensionally, I can memorize 3-dimensional things near instantly, and I always have been able to. I'd really love to try this out, see if it could help me with math or language, because I love studying language and aspects of programming. But I just have never been able to, because no matter how immersed, even if I travel to another country, I cannot get the repetitive methodology to help me ingrain the knowledge I'm trying to learn. Like, I've been to Costa Rica a lot. I can give you turn-for-turn directions around quite a few cities in Costa Rica. I can't give you any Spanish lessons, though.
Yeah, I think it's really exciting to think about as we learn more about what brain signals correspond with different behavioral effects and ways of learning. And then beyond that, we're still talking in such basic terms. Brain is obviously just one way of measuring what's going on inside there, and other people are doing interesting different versions of that. If we can get that precise to be able to say, okay, so we want to have a brain equalizer device that improves your ability to learn vocabulary. Wouldn't that be awesome? And unfortunately, we're at the very, very foundational stages of that. And what we're trying to do at home is we're just trying to get some results out of the lab, translate them into a device that can be helpful.
Yeah. Yeah, I'd love to try it out. Another thing I was thinking is, have you thought about trying to get some gamers to test it? Because I know in esports, they love stuff like that. Like, you know that test you were showing earlier, the Simon Says type one? That is actually used by quite a few esports teams to practice cognitive function of being able to be loaded into a randomly generated map, learn it very quickly, and then be able to learn how an opposing team or whatnot is going to move around it. Like, gaming esports teams love using early stage technologies. I mean, I know a couple teams that use any method that has even a chance of improving working memory or lowering cognitive load while increasing focus during even just a short period of time. So if you find any groups, I think they'd be really interested. Like, I know the Bay Area has an esports team, LA.
We did a lot of testing with esports athletes, actually, and you know, one of the interesting part of that idea is that when you've got someone sitting at a computer, you can take a lot of biometrics from them.
Yeah.
And they're, you know, like you said, willing to have them taken in order to improve, or at least some are. And we were measuring. I might actually grab up a video and just show you something that I think you guys will find interesting that isn't relevant to what my company is doing right now. But we worked with a couple of gaming teams for a little while, Cloud9, Ghost Gaming down in LA.
Oh, yeah.
Where we were measuring cognitive performance, and we built this system where we were feeding back to them a measurement of how stressed they were, how engaged therefore their working memory might be, those kinds of things, and then telling them, hey, we think you need the stimulation now, with the intention of building an algorithm over time that would be able to close loop that and get people to sit at a computer with a Logitech gaming headset with brain stimulation and EEG.
Yeah.
The problems were practically the industry is very nascent, and so selling it to the really high performers, they had a lot of other things being sold to them. It was kind of hard.
Yeah. Yeah.
But I think it'll get there eventually.
Yeah. Could also be really interesting in VR. Like, I'm getting access to a new VR headset soon, and we'll be trying to get the new HP Reverb G2 Omnicept, which has eye tracking, heart rate, and I want to build EG, and I was starting to think about TMS or TES, and this, from the stuff you've been showing, it looks like that is a very viable thing to add into the mix for testing.
You're right. Yeah. I think it'll be a really interesting application. And actually, some of the tests that we're doing now, working on now with UCSF, although they're not esports, particularly the Gazelle Lab is really interested in, and if you're familiar with some of the work they've done, like Achille coming out of there, with the NeuroRacer game being used to.
I dropped a link. Yeah, I dropped a link to the paper that one you did with NeuroRacer. Yeah.
Yeah. You know, it's not esports, but gaming and digital medicine through the combination of biometrics with the presentation of tasks on a computer is a kind of whole other side that may be part of the closed loop to this tech. And paired with stimulation, you get some really interesting results there too. So if that's something you're interested in, be happy to chat about it. And there's lots of good stuff to look at too.
Oh, yeah. Yeah, I'd love to chat about it. Like, I've been reading a lot more of, what neurotech and what VR stuff can cross over, and it's going to be very important in the future, and early days are always the funnest part of any new or emerging field. I mean, a lot of this stuff's been around for decades, but is only in the past like 5 years becoming accessible to like people to actually test it out. Yeah,
you're so right. And that kind of segues me to another really important thing that I like to tell people. It's not science, but I think you may find this interesting. I think that the reason this technology has been successful in labs for a while, but really found it difficult to get out, is that the technology just isn't designed for people to use. And there are good reasons for that. Obviously, electrocuting people's brains in the real world needs to be done in a very ethical and considered way. But an EEG device isn't a worrying thing. And there have been a couple of good applications of that with cheaper devices like the Muse headset and stuff like that, right? But we can do TACS in a safe and healthy way. We have done lots of studies that have measured it to be safe and healthy and effective. Pretty modest effects, very modest effects in a lot of cases. And I would say that Hum's effect scientifically is pretty modest too. But very cool that we can cause those effects to come about. Am I presenting my screen right now?
Yeah.
I am. Good.
Yeah, I love those prototypes.
A lot of Hum's work has been on trying to figure out how we can make a cheap and easy, unintimidating form factor that can be used to replicate some of the results of the labs. And we started with this TACS prefrontal cortex method. We've gone from, the standard big scary 3D printed headset down to these little tiny patches. And we've had to do, I'll be overseeing lots of studies looking at how people use them in the real world and how that working memory effect translates. And let me tell you, it's a very difficult business to run. We're kind of at the intersection of medical device and all of the FDA and those other considerations that come along with that. Hardware, everyone knows hardware is hard and everyone says it every day. We do have a lot of software considerations because we're trying to build a sticky platform, and neurostimulation isn't a thing that you put on and you go, I feel amazing. So you kind of need to build some closed little loop for people, like interaction loop, to make it sticky. And then just, startups in general. So yeah, it's an interesting company.
So I want to ask something related to you were kind of touching on there. I had two questions. One of them, I'll start with the second one, because you were mentioning kind of the medical device field, and so there's this company in the UK that are now doing the TACS with TDCS with a device that I think is pretty similar to yours. Or it looks pretty similar to yours. It's like a anode cathode stimulator over the forehead. So have you been, like, when you see that, does that kind of come on your radar? Are you kind of working towards that type of application as well? Or are you just sticking in the in the memory enhancement domain? And like, just in general, like, what's the kind of company device space in that area from the business point of view? Like, I don't really know. I can't formulate this question super well, but I'm just interested to hear like what it looks like to you from your perspective.
I think it's the early days of the internet. It's the kind of early 90s. No one knows what's going on. Everyone's testing different things, and we just have the added consideration of needing to do it safely. I guess I did too then, but electrocuting your brain sounds a little bit different to playing on a computer. So I don't think anyone has it quite figured out what the long-term path for the whole industry looks like and devices in general. But that being said, I think we all kind of have the same idea. We need to build devices that can react to the latest research, replicate those effects. That company that you're mentioning, there are a couple. I couldn't tell you which one you're talking about, but there are quite a few who do DC.
Whoa, neuroscience.
Cool.
Yeah, kind of, it's chunkier than yours, but it's a
Yeah, I mean, we are fundamentally all trying to do very similar things. But Hum in particular is really trying to focus on rapidly translating into very easy to use, unintimidating and cheap devices, whereas everything that's come before has been quite expensive. We're trying to make something very cheap, very easy, like as easy as a Band-Aid. And And along the way, we have also been really trying to build in this closed loop. And so although everyone will tell you that they're trying to build a closed loop, I think that we've come a long way and have got some really interesting ideas. The circuit that we've built into the prototype we use at the moment, this one down the bottom right, it can do any frequency, etc. of stimulation. It also has the capacity to have sensing stuck onto it. But for the moment, we've just got a very simple version of that circuit and a very simple battery set up with a very simple electrode. We really think the big barrier has just been getting people to use the stuff. Once you get people to use the stuff and demand it and enjoy it, you can get large quantity of people in both citizen science and home studies from formal universities and in labs as well, get them into labs and just do the studies faster. That amplifies the amount of data that you can get and amplifies the interest in the industry, amplifies the demand from customers and the understanding of the amount of research to be done to get people to feel safe and then actually want to spend money on this stuff. So we're Flow and Plato and all of the companies, including Hum, are all kind of bearing that burden of education and research and pushing this stuff forward. We all have a slightly different way of doing things. All of the companies on my radar, 90% of them are founded by good people who have the same things in mind as we do, and aren't looking to make $1 billion. If we wanted to do that, you'd probably be making some API for some B2B application, not this incredibly difficult. And there are 10% of people who are out there, and I won't name names, who are trying to build the IP castle and fuck everyone else over so they can win, but I think they're very silly. And I think that they think they're going to get acquired by Medtronic or something in the next couple of years. It's more difficult.
So those last comments to kind of segue into my other question a bit, which was kind of about the API and the again as a device thing. But it's like if I buy one of these things, what control do I have in terms of specifying frequencies, and is there like a programmatic control? Like is it wireless? Is there do you plug in? Like what does it look like? And especially from a kind of hacker point of view, like if you got a Python API, can I write code to design things, simulation things?
For the moment, unfortunately, it's very boring. It's designed for the common person in a way, or more like the early adopter common person who wants to use this to get the kind of nootropic effect of better daily performance. That's intentional on our part. Just because we're trying to make a splash and grow the company as fast as possible, get the most number of people to use it. We are, like you guys, the hacker kind of people though, and do want to be able to control. And that's what I do with this box here that I use instead of the patch that you can see on the screen already, and then we do in the lab with studies. But for the moment, just making this really simple device. Future versions over time will have more and more ability to control, and that'll come with greater expense and complexity in the customer experience, like the usage experience. And that's where we want to end up. For the moment, though, we're not doing that kind of stuff, unfortunately.
So I know, Josh, I just want to let Josh and I think Rochelle both had their hand raised.
Yep, they both did. I think Rochelle was first.
I think Rochelle was first, yeah. Go ahead.
Sweet, thank you. I guess I have a question around the business and the market. So the interesting thing about anything that like markets itself as a nootropic is that the people who want the product don't necessarily need the product, and the people who need the product may not know that they want the product. And so like your website very much markets towards people who are looking for that extra edge. But the people who really need your product are the ones who are, beginning cognitive decline. I'm thinking of like, my grandparents as they get older, that kind of thing. Like they would have like the best enhancement of life quality there. The FDA doesn't currently regulate TACS. So I was just wondering, like, is there a reason why you chose to focus on this market versus, like, for example, the elderly market?
Yeah, no, great questions. Really big topic that we could talk about for many hours, but I'll say a couple of specifics. So the FDA does regulate some TACS products that have very specific medical claims. They're very specifically a medical device. Fisher-Wallace is one of them. Cephaly. Fisher-Wallace does depression. Cephaly does migraines, and I don't think there are any others in the FDA, but the European group has actually started saying that it's going to regulate everyone that's doing transcranial stimulation, which is interesting. It hasn't happened yet. The Australian Therapeutic Goods organisation will probably follow because they're pretty conservative too. I think the FDA probably won't in terms of regulating everything that uses transcranial stimulation, but it could happen. So that's just the first thing. So there is quite a bit of regulatory, not oversight, I would say, but more like focus on this. It's quiet for the moment, but it's there, and there is precedent. That being said, the use of TACS in the method that we're talking about to improve cognitive performance for healthy people, a consumer application, not a medical application, obviously not regulated. That being said, you do need to be careful. We've been given guidance from the FDA that we need to not use the word memory too flippantly, and that's indirect guidance. It's stuff that they've published online. Don't let people who have Alzheimer's, basically, is what they're saying, think that they're going to be better, or have serious memory problems, think that they're going to be better, or ADHD, etc. I think they're ADD now. If they use your device, just because you're being too flippant with the way you're using the word memory. So we have to be careful there, and our company has to go through something called a 513G, which is like a pre-market approval. It's not a formal medical device approval with claims we have to measure clinical trials against, but rather it's an approval to say that we're not high risk and we're not causing people with medical problems to want to rely on our product, whether it's directly through our marketing or implied through something called shadow claims. So all of that said, we specifically decided to go for this consumer application. One, because we don't have to jump through as many regulatory hoops and it's faster. Two, because we've already measured that it's quite effective for people who don't have those medical conditions. And when I say measured, I mean we have a lot more data to collect. This is not a publicly available device yet, and there'll be more coming out before we do. But we're relying on some precedent data from the Causey lab and other labs, and our own white paper tests, of which we do more every month. And the other thing is, well, basically the whole answer is we just didn't want to be held up in the medical device pathway. That being said, I'm very interested in the medical applications. I'm also very interested in the applications that are not quite medical, but are bordering on it. And when you talk about, normal cognitive decline, and getting towards mild cognitive impairment, of which about 50% of people get dementia, and mild cognitive impairment is massively undiagnosed, we think, but 1 in 5 people over 65 get diagnosed with it. So it's a very big condition that a lot of people get, including my parents. I'm really interested in the applications to everywhere from that normal cognitive decline, bordering on the medical with mild cognitive impairment, all the way to Alzheimer's, but just want to tread lightly through a dangerous regulatory market in terms of, there's not a lot of precedent. The FDA does seem to be looking at it, as well as just ethically, like not letting anyone use it while the technology is still really nascent, that thinks they're going to get a fantastic result out of it. Like I've said, it's a pretty modest effect. This improvement in working memory, it's not going to go and fix your cognitive impairment or even treat it in a way that's substantially better than anything like exercise, diet, sleep, and social interaction. And so we're starting just by being really careful. And, we're not scientists ourselves, but we work with Xanto and a couple of other scientists on our advisory board. And everyone agrees that it would just be really bad for the industry as a whole if we were to go too fast, too hard. And if we had some negative result of, like, say something like visual acuity went down by 5% measurably while working memory was going up, and that would portray negatively to the public, and people said, look, this stuff actually hurts you, that's just as bad as actually hurting someone in a way, because it really slows down the industry's ability to commercialize and get the valuable technology in people's hands. So it's a risk-adverse path that we're taking. It's trying to be scientifically credible path we're taking, and it's a regulatory conscious of consequences and things path we're taking. It may not be the perfect path, but it's the path that we've kind of, as a company and a group of VCs and scientists behind us as well, have come together as a hive mind and said is the best one. So there's a longer answer. Yeah.
Well,
Rochelle, where are you from? It sounds like you're studying neuroscience.
I am not studying neuroscience. I studied computational neuroscience in college, but I've gone down a long route. Most recently, I worked at Palantir, which just IPO'd. So I've just been curious on both sides of it.
Yeah, cool. I'm sure there are a lot of really interesting people on all kinds of things, working on all kinds of projects in here. I know I've run out of time. I just wanted to say one very tiny thing before I give you back the microphone. So we've just started advertising for a senior product manager and a software engineer to join us. That being said, we're going to be hiring scientists and other people over the next couple of years as things continue to go better. COVID hasn't killed Hum. It nearly did. It shut down a manufacturer that we were working with, and we lost a lot of time and money on that, but we've come back. But yeah, if anyone's interested, you can email me. It's Ian, IAIN, @thinkhum.com. And you can have a read of the white paper and contact me through the website too. And I'd love to meet anyone who's interested in what we're doing. And yeah, we're based in Berkeley, so lab visits are a thing once COVID settles down too.
And one more time, what was that email?
Yeah. Can you write it in the...
Put it in the chat, please.
Yeah.
And we don't... we are...
I'm looking for a software engineering job.
I don't know if we can keep you some more, Ian, because I think there's definitely more questions.
Yeah.
So if you, unless you've got other things to...
I could come back in just a couple of minutes, but I actually need to go and jump onto a very quick phone call.
Oh yeah. Come back if you can.
Okay, sure.
And definitely make your call.
Okay, I'll be back in just a minute.
We will follow up because you're also on Slack, and we will be able to get your information.
Okay, sure.
So
also, before you go, can you write down your email in the chat?
I can. I figure out how to use the chat. Does anyone want to?
Chat is the very bottom to the far left.
Oh, there we go. Cool.
Yeah.
I'll be back in just a minute. I'll be happy to stay the rest of the night too.
I've got his email too, Rochelle. Okay, there you go. Yeah.
I'll be back.
Cool.
Thank you.
So awesome. Well, I mean, hopefully Ian will come back because I know other people have questions. I just wanted to say that I know that FDA is currently putting together guidance documents on TES, and I didn't find a good link to them yet, but I will, because I know I've posted it in Slack before, but I just don't know how long ago that was. Anyway, there's some good discussions about that in terms of like Ian was kind of alluding to, in terms of like what are you saying that you're able to do, and like, a lot of devices are currently sold direct to consumer, and are kind of not. Well, when they say FDA approved, sometimes what they just mean is that it is approved, that it's safe. It doesn't mean that it's effective. And anyway, so
yeah, more common is they say the science, and then they refer to a bunch of science on like research grade devices,
right?
Whatever. It's not like this device,
right?
And that's kosher companies everyone does that.
Yeah, or they compare their data findings to a actual medical device that costs a lot more. Like, I mean, Fitbit, Apple Watch, any device that has like heart rate sensor will refer to scientific papers about studies relating to like heart rate, doing things like being able to predict whether like a stroke might happen, all sorts of stuff like that. I know Aura Ring has quite a lot of medical research they do with their device, but I think that's also not actually considered a medical device. I think there's actually a FDA category for wearable, like biosensor something or other, because I went to a startup like event for wearable sensors, and yeah, they have to talk extensively about how important language is when on their website, any claims they make with their device, who they're targeting, because the difference is a decade, pretty much. It can be like a decade difference in when you release.
So I know Josh is here, and sorry, Josh, I know you also asked to have a question, but I think you've got something you wanted to show today.
Oh, me show today? No, the other Josh, not me, Josh.
Sorry, sorry, Josh.
Sorry, keep doing that.
I see.
I need to put my last name in next time. Sorry.
Sorry, Josh. Sorry, the other Josh. I just see these initials, but Josh, I believe, was going to show off his Hedgeduino, or this is Hedgeduino 2.0.
Somewhere at my first go at a headband here.
Okay.
It works. And then all it is just this little sensor, and it's just a maximum pulse oximeter sensor with some standard LEDs, and but it's spaced out about 3 centimeters. So hypothetically, that lets you do FNIRS, right?
Yeah.
Then the goal with this chip was just to get like really clean data out and start to be able to possibly look at like brain waves or at least pulse and blood oxygen types information. And then let me show my screen here. I've got to assemble like 60 of these tonight. Not tonight, but over the next couple days.
I'm not seeing anything on the screen yet.
Yeah, hold on.
Oh, okay.
So you sold 60 of them?
Yeah. And then I've got a few to give away. I got to send a couple to my friends down in LA because they're the Biofeedback Institute. They're super chill people.
Sure. So
they help them out.
If you could drop any links that we should add.
Oh, hold on. I got kicked out of the meeting on my screen. That's what happened.
Okay.
Let's see here. Hopefully my connection is dropped. I have like the least reliable internet. So it's so if you don't know what FNIRS is, it's just you're using infrared light, and then I'm using red light to compare the infrared light, and then pulse oximetry just lets you. It's just some math that uses this information to check or like to try to measure your pulse, and then the relationship between the red and infrared light can tell you about blood oxygen content. And then now there's like machine learning methods for getting blood pressure, and there's all kinds of other stuff. You can diagnose different arterial issues based off the shapes of the waves.
Sure.
Okay, where's the share screen? Oh, here we go. Okay, can you see my screen?
Nothing yet.
Not yet. Not yet.
Oh, that's why. I accidentally connected to my HEG. There's no internet on that thing.
Okay.
Okay, let's try. Okay. Okay.
Yay.
Yeah.
Yep.
All right, cool. And I'll just show my slides here. There's just a couple of them. Okay, so I just unplugged my battery, so all the noise went away. So you can see my pulse here. Let me show this. And then there's 2 peaks, and then that's your brachial pulse and your something. basically that's your heart opening and closing, and and then that tells you different things about what your heart is doing, obviously, and then there's some math I don't quite understand yet, but it lets you then calculate blood oxygen content, and it's like a really pretty simple little equation.
Sure, but what you were showing us is how pulse ox are giving us our.
Right. Well, for me, it's just kind of a baseline to let me know that this thing's actually working. And then this pulse I'm seeing here, I'm actually pretty sure that's just my scalp pulse. If I push really hard, it becomes a lot less obvious. So I'm not sure if I'm actually seeing a lot of actual pulse information from my brain, but most of that information is still like the deeper tissue information. There's just on top is the pulse from the scalp.
So sometimes electrodes can pick that up too, where it's actually the movement of the electrode because they're sitting on top of a vessel. I'm not saying that's what's happening here, but
this is the ambient line down here. You don't really see anything. Sometimes you can see pulse if the signal's really strong. So if I like wrap this around my finger,
and what are you sending? What are you sending this through? What's the software that you're using here?
Well, this is just Arduino, but then I have my own software here. Get set. It should start coming through. Okay, and then so I do this. I use this for biofeedback. This is kind of the OG biofeedback. You're just breathing, and you're trying to increase your score, which is correlated. Well, I'm taking the ratio of the red light over the infrared light, which so then as your blood oxygen increases, your score goes up, and your blood gets redder with more oxygen. And now my score is dropping because I'm flubbing. But so the kind of feedback people do with this is you just do breathing exercises, and you do a lot of like mindfulness or all kinds of like cognitive behavioral techniques. Like visualization seems to work pretty well for people. And the goal is to just work with that and then use this information to help you like cope with stress better. And it actually works as a functional type of brain exercise as well, because this seems to help in kind of a like or classical conditioning sort of way, actually build an association with your breathing and improving this blood flow in your brain. And that, I don't know, I've heard a lot of interesting anecdotes. I've been building my original kits I've been selling them for like a year now. And after this next order, I'm going to have to push like 500 of them out the door. And it's pretty cool. And so I'm starting to hear, things from people. And, from my reading with this biofeedback and, like the therapeutic techniques or whatever that you're supposed to do with this, there's like certain, you're supposed to see certain benefits, right? So people, because, you're supposedly improving your brain blood flow, then your cognition should be improving, your capacity for language should be improving, your memory should be improving, really anything like associated with your frontal lobe. And then your frontal lobe is associated with all kinds of other things in the rest of your brain and your body. So hypothetically, a lot of that can, get improved in an indirect way as well. And, it's just like improving your health in a very general way. It's just this is focused on the brain and breathing because, well, when it comes to therapy and the kind of people who really need help with this stuff, they don't usually have much education about this stuff. I mean, if any of us really do. And then, like, I don't know, it's cool. It helps. It really helps kind of set a baseline for people. And it seems to be therapy.
So can you say how does this this hardware differ from the last version?
Okay, yeah. It was just like an off-the-shelf kit. and I'll show you something more interesting. I haven't added too many more features in a while, but this one it just has this nicer Maxim chip, and then the assembly is a lot simpler and more sleek. So it's really small, and then the Maxim chip is 19 bits, whereas the original one had a 16-bit chip. Although I was getting 15 bits out of it, and so this one's a lot clearer. It's using 2 photodiodes, like instead of 1. So I'm averaging the signal, and I'm getting like was it 4,000 samples per photodiode per second? Or yeah, and that's really good. That's like super high quality. And if I go back to show you the graph again, you can see that the signal comes through really clear. That I was dealing with.
You're breaking up quite a bit too.
Okay. How about now?
That's so far so good.
Let's see here. Okay, so what else? So this is all open source. All the information on GitHub, all the plans on GitHub. I'm selling my assemblies with like a headband and some stuff, to make it wearable for people for $75. And then you get the sensors by themselves for what I have them listed for 35. And then if you want to make them yourself, it's really not too bad. Well, it's bad until you book order, but I can help you with all that. And the point of this is it's a really interesting sort of less talked about area of neurofeedback, and I've seen it do a lot of really good things. And I was really disappointed that this wasn't more accessible. And a lot of the existing technology. I mean, I think the latest cheapest one now is Indy, which is like $300. But this is just like, it's like $10 worth of parts from Mauser, and assemblies are super duper cheap. But like, sure. Whatever, it's still cheaper than a box, and it's affordable, and I can do that.
Okay, well, hey, we've got to. I've still got to cover some Ross Neuro before we then cover some of the what's happened this week and what's happening next week. But yeah, drop some more links in terms of where are the places that are selling this now. We didn't get our update. Hopefully next week we're going to get our update on the hardware hub. NeurotechX hardware hub. So I thought Ben was going to drop in this week, but since we'll hopefully have a meeting before next Thursday, we'll get an update. And I know that at least I think is it the older version or the new version will be available from the hardware hub, Josh?
I'm sorry, repeat that.
When the hardware hub is live, will it be the new version?
Yeah, and there'll be
okay.
Yeah, I'll this the board list, and there'll be like a discount because that's
okay. Great. And
next week as well.
Yeah. So just because I don't know if John K is still, he's on the East Coast, but absolutely relates to the Rensselaer lab that John. Let me see if I can find that again. It was like the non-invasive simulation. Do you still have that link, John? Or did you drop that? Yeah. Sorry, it's in the. Oh yeah. This is so really interesting that that this would come up just in terms of the Rensselaer group and the Center for Modeling, Simulation, and Imaging. And what you can see is, of course, this typical banana shape between sensors, which really holds it with both electrical as well as optical signal detection. In terms of like this is ideally the path that the whatever you're injecting in is taking between the two. And anyway, so this is some of the modeling that gets done in SimNibs, and Roast is the other tool that Ian mentioned from I think that's Paris Lab in New York. But anyway, if you go to their software projects, you'll see this is they're very much using like finite element modeling. PETSI, which is typical parallel solver using MPI, and then this interactive medical simulation toolkit from VTK. So I'm just mentioning some of those because, of course, if you go to ROS, sorry. Well, some of what the ISMTK is using are these same dependencies in terms of things like potentially, I forget what ISMSTK uses, but what you'll see in a lot of the simulation packages is DART and bullet time, and what are some of the other examples? And I mean, Mujoko is what OpenAI uses. And let me just share this. And I can't quite see. Oh no, that's the second one. Sorry, it's giving me a window, or I've got to select it from a very small number. Is it this? No, that's the same one. Sorry. I'm not sure why this is okay. Okay, so Ross Neuro. Okay. Yeah, so this is an attempt to bring to the robot operating system basically EEG and other biosignals. And what is great, I mean, you might recognize here some of the tools that we know. Certainly OpenVibe, which is currently what the free EEG32 works with. Long time BCI package from France. And I never used BCI 2000, but BCI Lab is the MATLAB toolbox that from San Diego, or Christian Coto's work. And I kind of looked up a couple of the others. I thought it was interesting that Toby's got something. But so here's a bunch of robot people that they've seen the kind of like our existing tools, and decided to bring this in into ROS, where ROS, every process, you have to just do this kind of like conversion of terminology, a certain translation. So a node is a process, and so you're giving, but this is very much like LSL in that, every process is running, and it's a kind of publish and subscribe model. And there's some additional things in terms of like, are you looking for a particular kind of thing? And, you've got various categories that you're advertising as providing. And so, a person can list those running ones and then pick up a stream. And, again, it's very, very similar to the lab streaming layer, terminology. And they've got, so I like that their GitHub, that is not, their project name is not blah, blah, blah. And they do have a real, they have a real GitHub, which I forget if I put in the meetup agenda, but I was just wondering if anybody was actually familiar with libeeg. So one of the things that they're obviously trying to do is, as much as possible, they don't want to recreate the wheel if it exists, and so they're using this particular layer between various amplifiers, and then just wrapping this as a ROS node. This isn't what? Well, anybody familiar with this? No. It didn't. Let me just. Just see who that was. I wonder if this is like an old, it has the feeling of like an old, no longer maintained package, but anyway, it did seem to support a number of devices, which was kind of cool. And I've never looked at a lot of the lab streaming layer, or like how if lab streaming layer in it does have a number of devices that it supports. If it ever uses a dependency that's trying to give it some abstraction of hardware, kind of like BrainFlow, or whether essentially like BrainFlow would be a more modern, better dependency to work with in providing this this kind of like wide hardware support. But that was the first question I had in terms of like, would you use this libeeg dev? Would BrainFlow be an alternative, and or would MNE CPP and the kind of the kind of hardware support that it gives you be a better and an active project on which to build? But I can see what they're trying to do, in terms of like and I think, well, see what they and then when it gets to testing, I've felt in very familiar territory. Certainly they're using I think it's libxdf. So that is also certainly what other people are using, and it's now one of the, I believe, supported formats in bids. No. So in terms of writing out, I wasn't so much worried about that. Interfacing with systems and then being able to provide very fast. I mean, what they was it later? What they are really working on is like how quickly can other nodes access information from their their EEG information, and so this is this is the first paper, but then let me just show you this. The second one definitely does more in terms of right. So again, the same people, and this time a little bit more focused on just one, can they compress the information, and a lot about latencies in terms of how well they can pass that on to other nodes. In this case, they are using, guess what, a data set that we have in Moab. So it's this example isn't data that they've collected. They're just working in simulation. But again, that's the beautiful thing about ROS, is that like ROS when running, it doesn't actually matter that you have hardware connected. It's really just passing it to the middleware layer and then getting it to another node. So this particular data set that they've got, that if you look up, is this 61 channel biosemi data. And what I did think was interesting, and we don't use, is that they had a glove. I don't know where it says that here. Yeah. So EEG data, along with motion and coming from this glove system. I thought that was actually kind of cool. And oh yeah, so here's the data set here. But this this is an archive paper, and so this is I forget if it was like August, I think it was pushed out. But I mean, it's not, it's sort of interesting what they're trying to do with deep learning here. And certainly, again, like the focus that they had in terms of how quickly they could do, some sort of meaningful compression was really interesting. But what they really wanted to get was, what they could do, and yeah, how quickly they could do it. And these are some of the things that they've computed on these subjects, which again is really interesting because, of course, we have this in Moab, and so things that they're trying to do, we could also test against, and it's not something that I think Moab has focused on in terms of how better how much better we can do in terms of dealing with more real time, like how responsive we can be. But so like Moab has definitely been an offline kind of testing tool, and this use case is much more interesting as what are the best things to do it in real time. And okay, we've got a few more links. So just wanted to bring those up, and yeah, if you've got applications, Jaden, that would be cool. I don't know if everybody saw Jaden's link to the challenge, the X Prize challenge, but that looks awesome, and it's full robot control though, right? It's not exoskeleton. I mean, obviously, exoskeleton robot, it's kind of the same thing.
Yeah, it's a full humanoid robot,
right? And I mean, I guess with the exoskeleton, it really comes down to the fact that like you potentially have these other inputs to the system. Like if it's a person who can move, like
right?
There was there's definitely some recent exoskeleton suits, exoskeleton units that for people with various injuries. I saw one where they were like had them skiing in Switzerland, or like going through like thick, like deep snow. Anyway, just one last. So, yeah. Wasn't sure if everybody is familiar with the NeuroRobotics platform, but we've talked about this from Human Brain Project, which is a super well funded project in Europe that had six. Well, yeah, it still does have like six main. Well, they call them pillars too. One of which is neurorobotics, and one of which is neuromorphic computing. And so neurorobotics.net is I'm getting used to the new stuff, because this eBrains, which is yeah, a lot of their stuff. I don't know if John, the backstory of this. Is it because of new leadership? It's
well, the new leadership was a while ago. Oh, you mean the recent?
Like, why is it all eBrains now?
No, yeah, no. I want to know that too. I don't know the story to that, but it seems like they kind of have transitioned to what they have decided is going to be their brand going forward.
Yeah,
like they want to not be HBP in the 2020s or something. Maybe they think there's too much baggage with that.
Sure.
It seems like some kind of strategic marketing thing. Sure. I haven't seen any explicit information about it. I'm curious as well.
Well, I mean, yeah. So that's why I'm not. I'm having a little trouble navigating around on this particular webpage. But this NRP 3.0 is what I'm familiar with, which is it's ROS. It's melodic based ROS, which is like a particular so these ROS has its own name, just like Ubuntu, and it actually kind of targets particular Ubuntus. So when there's a new Ubuntu release, there's usually, or there is always, I think, an update to ROS. Yeah, we have it. There's you can also run this on Fedora, and for those who are interested, I can tell you about that. But if you want to test this and you want to get support from Human Brain Project or eBrains eBrains, you will use 1804 and build on this, and it's pretty easy if you are also quite comfortable with shell scripting. And honestly, most of the problem is the other stuff that they add, which is like they've got their own web viewer. So they're using a web interface. Think of it like kind of like using Jupyter, like a web interface to the simulation. And so this GZViz. Anyway, let me see if this page looks the same. But Yeah. Let's see if they've got better pictures. So, yeah, I mean, there's a robotic rat, and you can put this robotic rat in a Y maze, and which is kind of like an old psych experiment. And anyway, that's partly why I think he's holding the neurorobotic mouse. But you also, for those who are kind of familiar with, intro or teaching robots, Turtlebot is there. And I think it's Turtlebot v3. Again, I'm not really sure how to navigate the website anymore. Okay, so this is actually new to me, but okay, so the way ROS, part of the way ROS also works, and it's got its own file formats and things like that. So if you want to build another, a robot to use, you have to construct some geometry, in the environment, and then give it, essentially physics in terms of like it's got an axle and things like that, and wheels, and then the physics simulation will know how to make it respond. And they're very, it's like it's kind of, for those who are coming from neuroimaging or or say source imaging and EEG, like it's got geometry file formats that you've got to use that are some of the dependencies in ROS. And I don't know this cyberbotics. Anyway, I think it would be really interesting, to have a look at this, and because you can run a simulation without a real robot, like what we really need to work on is just like, can you inject the EEG data into the system? So in the same way as, say, Kushal was saying, like, can I use my Muse alpha power to turn on a light bulb? Well, could I do the same thing to make the robot go forward, right? Just like nothing fancy. Fancy would be some of the data sets that exist, which are like exoskeleton control, which is this like what Arvind described in terms of like 6 circles, where it's like you're looking at the circle that you want the robot to move, direction you want the robot to move. And yeah, I think there's some really good overlap in these particular papers. The autoencoder paper actually uses Yannick's paper on overview of deep learning in EEG is like the first reference, which I also thought was cool. And yeah, so I mean, there's really easy, intros to playing with ROS and getting simulations going that you can also just do inside a Docker container too, of course.
What autoencoder paper were you referencing?
That's
super cool.
That's the second one. So again, if you check out the meetup agenda.
I have it up right here. Don't worry, Morgan. I read the meetup agenda.
Of course you do, as we all do. No, it's okay. It's the at 8 o'clock, it's way past 8 o'clock. It's the archive paper there. Yeah. And so since it's like 10 minutes left, just wanted to say, okay. So somehow I didn't get one update, which was that, next week is MCI. So I don't know if, for those not familiar, that's the medical image, and what is it? Artificial intelligence? No. I forget what the acronym stands for, but it's where you see a lot of good neuroimaging work, especially with registration, segmentation, and this kind of geometry formation. There'll be lots of like shape analysis. That's where the big brain tumor grand challenge competition takes place, is at McI. So Bratz challenge will be they'll, I guess, announce the winner. But BCI Samara is the big BCI meeting that's next week, and they're doing a lot to make it internationally accessible in the sense that like they're going to have the talks at times that are really helpful for people in time zones outside of like central Russia, which I think is Samara is pretty central, I think. Anyway, check that out because they got great. That's I think it's co-sponsor, or like NeurotechX is definitely involved with BCI Samara, and of course they put on, or they were big sponsors of the BCI 101. And Mikhail Lebedev gave the keynote for that. But live MEEG is also next week. So again, like check out all these links. See what particularly appeals. I'm gonna just drop in the McI one because and also this weekend, or this last weekend, was PrivacyCon, which was the Open Mind conference on like privacy, federated learning and machine learning without that allows you to keep your data private. And I'm trying to remember the speaker, but it was a speaker from the Trend Center in Atlanta, spoke on CoinStack, and you can definitely check out the YouTube on that. So yeah, I mean, when we've talked about this a little bit in terms of like how we could be doing the same thing with EEG, and if you check the recent, for those that use Archive Sanity, if you just put in EEG, and like this summer, there's definitely some good federated learning EEG papers from the particular subsets of archive that Archive Sanity includes.
Yeah. There's also GTC, which you mentioned before meeting. Yeah, GTC is next week. So graphics technology conference, which like it's hosted typically by NVIDIA, but there's other groups, and like some stuff can be very similar to SIGGRAPH in demonstrations, but GTC also has a lot of much deeper looking at how graphics, AI, and different types of things can be applied to graphics. So they often discuss things like a system called DLSS, deep learning super sampling, which I've read a couple of reports about using super sampling techniques on different types of neuro data, because it's like
you can hear us.
Yeah,
yeah.
Are we live in Noisebridge?
We are live in Noisebridge.
Hey.
Yeah, sorry, Morgan. As Dan and I were a little busy crawling through the walls at Mission,
No. I know. Yeah, I mean, you guys are doing good stuff to get the facility working. So anyway,
We're ready for you to bring that 256 channel amplifier project in here.
It
space in the music room upstairs.
A lot of space.
We've got two, and they're both right downstairs.
All right, just come on by. The water's fine. Happy to show you around.
Yeah.
I heard you talking about brains and wanted to say hi.
Oh yeah, I just wanted to say hi.
Yeah.
I was just listening to what you guys were saying, so I'm gonna be ear stalking you guys.
Yeah. I mean, we're almost over, but like, if anyone wants to stick around, I think I might talk a bit about the HP's new VR headset and what it could mean for biosensing and neurotechnology.
Actually, I wanted to talk to you about the one Blender project you were working on, where you were laying out noise bridge, right?
Yeah, and I actually need to try viewing it in VR.
Well, I would love to help you start modeling it.
Yeah, we'll talk about that after the meeting.
All right.
And yeah.
So I just wanted to wanted to mention two things actually. One, Neurotech or the student chapter of University of Toronto, John, right, has started a intro to neurotech class.
Well, they've been doing that for a while. The syllabus has been developed.
Gotcha. Yeah, I mean, but it started September 28th, right? Or,
Right. Yeah. Yes. I think they're running this term.
I mean, it's and I don't know if sorry, I guess Kashal's not with us, but anyway, I think he was going to try and take that, and I was curious to hear feedback. The other thing was this. This is NeuroHub, that is open beta right now, and what I thought was interesting is that you can. I mean, one, that you can store data, but two, that you can work on UK Biobank. That's and for those who don't know, like that's such a massive data set that it's doing some really interesting work when effect sizes are small. Have you heard anything about this, John?
No, this is news to me. But so you get access to biobank data like straight away. It normally takes months to get biobank data access.
This is what I know. So tomorrow is the ReproNim, I believe, right? It's October 2nd. I think ReproNim group is going to do a talk, and I think JB Pauline is doing the ReproNim talk tomorrow. I can try and find a link, and anyway, I believe this is JB's, JB's baby, or certainly he's on the advisory board for this. I mean, in the sense that like this is definitely like an open science effort that sounds like the kind of thing he would have been pushing. So maybe we can get
right. Okay. Healthy Brains, Happy Lives, McGill, the Neuro. Yeah. This is interesting. This is something that they. Sorry, go ahead.
Well, no, I see at the bottom it says Principal Investigator JB Pauline. Yeah. But
yeah.
NeuroHub Director Brian Karen. I don't know.
I've heard stuff about this kind of thing a while ago. I mean, there's actually it looks like it's to some extent borrowing the model from Dementia UK.
Huh.
If you saw that, but that's a portal that has a few data sets, big data sets. I can't remember what they are now, but ones that you have to kind of go through quite an extended sign-up process and access process, and they including Biobank and CamCan, and they like through their portal they give you computational resources and access to data and so on.
Sure.
And it was actually really well put together. I never really had the occasion to use it, but this looks pretty kind of inspired by that, I guess. And I know that one of the other things that might be underneath this is that the one of the ideas behind NeuroLibre was to have a binder instance that has a decent amount of compute and access to data sets.
Yeah.
In particular, kind of cached access to data sets, like certain things that you often use. There's a lot of neuroimaging data sets in particular that, like, subject 100307 from Human Connectome Project, that people use those files so often that you might as well. It does make sense for some things to actually like have them actually cached in memory because they get used so much. So this idea of having a kind of souped up binder instance that has data access and compute, so it's like binder with added value, binder with more,
I mean,
more bells and whistles. This might be the instantiation of this. Or at least it sounds like it's going in this direction.
I mean, would be almost guaranteed, right, that this is binder based.
But I don't see any mention of NeuroLibre. I thought it was NeuroLibre was Pierre who was talking about this. Not
okay.
Yeah.
I want to look that up.
Pierre Bellet.
But I did drop in a link for those interested for the Reaper NIM, and you can catch the webinar tomorrow. It's beginning of the month. First Friday is Reaper NIM's webinar, and as well as links to the previous ones. And I just wanted to say that we are, after the discussion with Neuralink and BCI, we're trying to start this invasive NeurotechX SIG, and one of I think the last speaker was Satra Ghosh, who's the Dandy Archive PI and developer, and so definitely a good webinar to catch if you were interested in working with any invasive data. That's a Brain Initiative funded project to make that kind of intracellular and extracellular recording data publicly available. And yes, so, and yeah, Devesh, hopefully you can come and tell us about the Neuroscience Gateway portal, your actual experience with it now that you've got an account. So it's after 9. I'll press Ian, see if we can get Ian to come back and talk more about Hum, or maybe about the issues of like whether you're targeting a medical problem or if you're trying to stick to being a consumer device. So let me know what are well, yeah. If you've got things that you'd like to hear more about, it would also be really helpful. We can get somebody to come and talk about those particular issues. Like Ian said, like he wasn't necessarily the best person to go into all sorts of the science details on, say, TACS. But but he can definitely, and I've heard him speak on in terms of entrepreneur talks and getting a startup going. That is something that he could definitely come back and talk more to us about.
It can be very helpful to hear about like the startup timelines and stuff for like, I know I've been very lucky with events I've gone to where they've discussed device and federal and international like requirements and stuff, and when you should be going after them and stuff like that. And I don't think we've ever had a discussion like that in any of the streams, at least, because anyone who's looking to get into hardware really should learn that very early on, and most don't, and that can really set a person back.
If you are one of those people that are interested, I really recommend the MSRI workshop that was a couple of weeks ago, right before the Neuralink announcement. So it was clinically implantable devices, clinically implanted devices. They had great speakers from the FDA and from DARPA in terms of funding and regulation, as well as lots of great entrepreneur speakers just talking about, you know, bootstrapping startups and things like that. So I will thank our videographers, Ryan and Alex, and yeah, the other, I just want to also put it out there. We're still looking for volunteers helping kind of manage some of the infrastructure of Hack Night in terms of, in particular, if we could use a lobby for Jitsi. So, and of course, also looking for anybody interested in kind of running some of the other duties of the chapter. So if you're interested in becoming involved, please get in touch with me. And we are trying to get our live streams back, and you know, with help from Noisebridge and others.
Maybe even be able to have some stuff moved, physical devices moved over to Noisebridge, where like someone like could go in and show how to use an actual device, or we can have a speaker actually come into a physical space and demo a device alone or with one other person. Because like, right now we're missing hands-on, which for people online who haven't been to any of the physical events, we actually usually did do a lot of hacking and programming of actual devices and testing them, which right now is very hard to do over a meeting like this.
That is something that I can also try and help arrange if you know, if that would be of interest to people. Yeah, even if it can't necessarily happen at Noisebridge, I can think of at least a couple lab spaces where that could be done safely. And so good deal.
Events at Noisebridge, and a mental reminder about 5 Minutes of Fame on the third Thursday of October. That's the 15th.
Yeah.
And we have a fantastic socially distanceable driveway and live stream. So call for presentations, in person or remote. 5 the number MOF, 5 Minutes of Fame, 5mof.net. And there's a link there to October's event page. It's a wiki. You can edit it. And add yourself or ping Ryan or any of us. But, would love to have 5-minute talks.
Yeah. I mean, I'd love to be able to showcase a couple NeurotechX things that would maybe get people interested in.
It's it's NoiseBridge are going to start to try to have more events. We definitely want NeurotechX will probably be some of the first stuff like these hack nights, figuring out how we can do those safely, because this is a field that it's very important to allow people to get hands-on with equipment, because so much of this equipment up until recently was inaccessible for anyone except a academic researcher, and even still is generally not as accessible as it would need to be to get larger scale adoption or larger scale data sets. I mean, luckily with the work for the notebooks, that's very helpful, and all the data sets that are finally public. Yeah.
We'll work on those, and let's keep talking. You can always find us on Slack, and yeah, thanks always to those on the East Coast that managed to stay with us till past midnight. Thank you, John.
Do our best.
My pleasure.
Yeah.
Yep.
We'll definitely talk about the HP reverb later.
Yeah, I think I'm going to make a short presentation for next week or the week after, like a 30-minute presentation. I want to do a bit more research into exactly how they're allowing access, because they've said very confusing things about how to access the sensors and their data streams and what they're going to support. So it's kind of confusing right now. Also, we don't know the price or the release date.
It's going to be like, I swear, if it turns into like a $10,000 thing, I'm going to flip a table.
I mean, they are going to be competing against the Vive Pro I, so it will be under $1,800. Which, I mean, considering how much eye tracking adds in value, is way more than it adds in cost. Like, the actual hardware for eye tracking is, like, good eye tracking can be like $30 to $50. But they always cheap eye tracking units with data analysis tools are thousands of dollars.
That's where they get you. I just got one of those second generation Tobii headsets where camera and then their sort of setup. It's not their newest ones, but play around with it. But connecting it up to Unity and the other sorts, that
adds $2,000 just straight up. Like, you want our low level API? Give us money. Like, I feel I've heard they might even do a subscription model for certain access, which I'm
Brian, don't speak this into existence, but I totally feel you on how much that would suck.
Yeah, I need to research more. I'll talk about it either next week or the week after, and hopefully I'll be having access to one of the Reverb G2s right when it actually comes out. Sadly, I don't think my computer could run it. I really want a new graphics card.
But they're all sold out?
Yeah, or no, they're all on eBay for $70,000.
This is also true.
Yeah, okay.
Right. I'm looking forward to it. I'll see you in a bit.
I'm ending the stream. Anyone wanting out, I'm free to talk afterwards.
I'll see you guys next week.
Hey, we're still live on NoiseBridge Cap. if anybody wants to virtually hang out at Noisebridge.
Yeah.
Can you drop them a link if they're interested?
Yep. Yeah. Wait just a sec, because I do want to talk with the people over at Noisebridge right now.
See you guys.